بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. And I would like to welcome you guys to a new chapter. It's an easy chapter, by the way, in which we are going to talk about compressors, inshallah. By the way, compressors, as we are going to see during this video, are mostly very similar to the pumps. So if you still have, the information that had been already covered in the first chapter, the pumps, studying this chapter, inshallah, will not take a very long time from you. I mean, the maximum time that it will probably take will be around 2 hours. It depends on your understanding of the first chapter. Okay. Now let's begin with the definition of compressors. Okay. So compressor is basically a machine that is used to increase gas pressure or the pressure of a gas, and you can see here that it puts the phrase compressible fluids between parentheses. Inshallah, I will talk about it. And the function of the compressor is basically to reduce gas volume, increase gas pressure, and moves the gas in a piping system. Now, this definition from my point of view is kind of misleading, and that's why we need to rewrite this definition. Okay, so I'm going to use the whiteboard. Okay, compressors are basically our equipment used to move gases from one place to another through the piping system. It is the same definition as the pumps, except that you replace the word liquids with gases. Okay, and the way or the mechanism of doing that, or the way compressors move liquids from one place to another, is by increasing gas pressure. The way it does that is by increasing gas pressure. Now, very similarly to what we have said before in the pumps, okay, if we have a fluid, whether liquid or a gas, at point A, all right, and you'd like to move it to a point B. Okay, the pressure here at point A, named P1, must be higher than the pressure at point B, named P2. Okay, so this is very essential, and that applies for both liquids and gases, guys. Now, if you want to move the gas or liquid from one point A to point B, the pressure at point A must be higher than the pressure at point B, and the opposite is true, guys. If you have a gas from B and you'd like to move it to A, the pressure at B must be higher than the pressure at A. Okay, because we have already discussed that the driving force for fluid flow, and what causes fluids to flow essentially, is the development of pressure and creating some pressure difference between the 2 points. Okay, but the thing that we would like to discuss here, guys, I'm going to erase this. Okay, is basically what are the differences between liquids and gases when they or in a way that explains how you can move them or how the pressure is increased. Now, first of all, guys, let's try to share with you the main differences between liquids and gases and why, and you will find by the end of this discussion why handling liquid systems and pumping processes are generally more easier than compression systems that are designed to increase the pressure of a gas. Now, the first difference that we have between liquids and gases is that liquids, I'm going to have to increase the size of our font, okay. Liquids are classified as incompressible fluids, okay, whereas gases are compressible fluids. What does that mean, guys? And this is, by the way, not mentioned in the book, uh, and it is very important for you guys to understand this. What do we mean exactly by liquids are incompressible fluids? It means, guys, that basically increasing liquid pressure will almost make no change or will result in almost a no change in its volume. بمعنى إذا عندك مادة سائلة، هو أغلب المواد السائلة إذا ضغطتها تقريبا ما راح يكون عندك أي تغير في حجم المادة السائلة. And the reasons are very obvious based on what you studied in general chemistry. Okay, liquid molecules have some kind of bonding, okay, or there are bonds that bond liquid molecules. المواد في حالتها سائلة جزيئاتها بينها روابط تربط ما بين هذه الجزيئات. That's why in order to reduce the volume of liquid, you will need to apply a huge amount of pressure. عندك مادة سائلة وتبغى تقلل حجمها under the same temperature, guys, you need to apply a huge force or a huge pressure. لازم يكون عندك ضغط عالي جدا جدا، وهذا الضغط العالي جدا ما راح يغير في الحجم إلا شيء بسيط جدا لا يكاد يذكر. I mean, whereas gases are compressible fluids. Now, we all know that materials in the gaseous phase, the molecules are not bonded together. ما في أي روابط ما بين جزيئات المادة في حالة الغازية. Every molecule travels in its own path. كل جزيء الحالة في مسارها الخاص داخل الكونتينر الشاب. So that's why gases, they take the shape of its container. الغازات يا اخوان كمان شكلها هو نفس شكل الكونتينر اللي موجود داخل الغاز. بينما السوائل لا، يعني it could partially fill the container. جميل يا اخوان. Now, since we have almost no change in the volume, okay, that will definitely imply that there will be almost no change in liquid density. Because we know that density is equal to, the simplest definition is that density is equal to mass per volume. كثافة تساوي كتلة تقسيم الحجم يا اخوان. ف if you pressurize a certain mass of liquid, and this liquid is incompressible as we all know, the density will remain changed or will remain unchanged. ما راح يصير أي تغير في كثافة المادة في حالتها السائلة يا شباب. Okay, بينما whereas gases will experience significant change in its volume. Why, sir? Because very simply, the way or the most common way to increase gas pressure, okay, inside the container is by reducing its volume. يعني في طبعا ان شاء الله راح نعرف ان في طريقتين، بس احنا نتكلم عن الطريقه اللي حقت الكمبرسورز. The way compressors increase gas pressure is by reducing the volume. You apply a force on that container. As an example, if we have a container like this, okay, with the piston at the top, okay, and we have gas molecules inside. The way compressors increase gas pressure is by applying a force in order to reduce the volume of the gas. هذه الطريقة إخواننا اللي تعتمد عليها compressors إنه how we can design a compressor in a way that the volume of the gas trapped inside the casing or the cylinder is reduced, and as a result of that, gas pressure will increase. But you can apply that force and the piston will move downward, guys, and that's until it reaches a value where you would like the discharge pressure to be maintained. Now, if you have a liquid inside the casing, guys, and you apply the force, okay, you will see that it doesn't really matter how much pressure you are applying, the liquid volume will remain mostly the same. ما راح يكون في أي تغير تقريبا في حجم المادة السائلة، وهذا الشيء إن شاء الله راح نشوفه بعد شوي يشرح ليش إنه التعامل مع المواد السائلة أسهل بكثير مع المقارنة بالمواد الغازية. طيب شباب. Now, since there will be no change in the density, there will be also no change in the viscosity of the fluid اللي هو اللزوجة. جميل. معدل اللزوجة تقريبا بالنسبة للسوائل under pressure will يعني will change يعني will not change that much. I can say that it won't change that much. The whereas gases, gentlemen, if you apply huge force and reduce the volume, you'll expect gas viscosity to change. Okay. And the other thing that is very important to notice when it comes to differences between liquids and gases is that increasing liquid pressure, okay, will, and we will say it will not change its temperature. عملية pumping or increasing liquid pressure will almost make no change or will not lead to almost no change in liquid temperature. ففي السكشن والdischarge يا اخوان لو كان عندنا مثلا يعني during normal operation, if the pump is running within the normal operating range, okay, you will see that if you have a thermometer before the suction and the discharge of the pump measuring water temperature, you'll see that there is a very minor increase. في زيادة لكنها بسيطة جدا. هذه الزيادة ما تأخذ بعين الاعتبار. That's why it is very likely that you will never see a pump, okay, with a thermometer before and after. A thermometer at the suction and the discharge to measure the temperature. يعني ما أذكر إني شفت فيه pump في يعني البروسيس مصمم بحيث إنه فيه مقياس حرارة قبل ومقياس حرارة بعد. جميل. Now gases on the other hand, جميل, will experience a significant increase in its temperature. راح يكون في تغير وتغير كبير في درجة حرارة المادة في حالة الغازية if you compress the gas, because let's go back again to the drawing, gentlemen, and and try to imagine what's going on here when you compress the gas. Now, as I said, guys, before, every molecule travels in its own path, and those molecules collide with the wall of the cylinder, as well as colliding with themselves. الجزيئات تتصادم مع الجدار حق السلندر وتتصادم مع بعضها الآخر. أخوان جميل. Now, if you compress the gas and reduce the volume, you will reduce the space. جميل. And reducing the space will make the molecules collide at a much higher rate. يعني معدل تصادم الجزيئات الغازية بسبب انك قللت الحجم راح يرتفع بشكل اكبر، وعملية التصادم هذه تطلق طاقة حرارية. اخوان، هذه الطاقة الحرارية راح تتسبب في ارتفاع ملحوظ، وارتفاع بعض الأحيان يكون كبير في درجة حرارة الغاز المضغوط. So that is actually the biggest difference between liquids and gases, is that the change in temperature is almost negligible in liquids، يعني تغير درجة الحرارة يعني غير ملحوظ ولا يؤخذ به، بينما الغاز يا اخوان the suction temperature and the discharge temperature will vary widely. راح يكون في فرق كبير ما بين السكشن temperature والdischarge temperature. That's why in compressors, guys, measuring the temperature at the suction and at the discharge is very, very important, okay, to determine or to determine compressor performance. عشان نحكم على أداء الكمبرسور، أحد أهم الأشياء لازم أراقبها اللي هو السكشن temperature والdischarge temperature. جميل. هذه أبرز الفروقات يا إخوان اللي تشرح الفرق ما بين الليكويدز والجازز. جميل. يعني I can also add a difference. Okay. Okay. Increasing liquid pressure. Okay. From low pressure to high pressure can be done in one step. خطوة واحدة فقط، اللي هو إن عندك pump. That's it. Liquid flows through the suction. It gets or it experiences a significant increase in its pressure because of, as an example, rotation of an impler or a screw or a loop or a movement of a piston. Okay, and it moves at a discharge. That's it. Suction, pumping, and then discharge. Compressing a gas, or whereas compressing a gas from low pressure to a high pressure needs to be done in multiple steps. بينما الغاز يا إخوان، إذا عندك مثلا ضغط منخفض جدا مثلا 1 atmosphere and you'd like to compress the gas up to 40 atmosphere, you cannot have like a single compressor, suction and discharge. Okay, it has to be done in multiple steps, which I will cover inshallah in this video. Okay, given the centrifugal compressor as an example. طبعا شباب, the reason I can initially discuss the reason here is that it is basically due to the significant increase in gas temperature. إذا تبغى ترفع البريشر حق الغاز من 1 إلى 40 درجة الحرارة راح تزيد زيادة خرافية. That will affect the mechanical parts of the compressor. ارتفاع المهول في درجة الحرارة هذه راح يأثر على الأجزاء الميكانيكية للكمبرسور. إما إنه من خلال أن المعدن يتمدد. And if you have metal expanding, or metal expansion, guys, that will create more clearance, راح يفتح فراغات أكثر. And that might result in a leak, ممكن تسبب في تسرب عندك. Or يا شباب, it might يعني cause some of the mechanical parts to break down until or under thermal stress. فالضغط الناتج عن الزيادة المهولة في درجة الحرارة ممكن يسبب لك كسور أو ضرر في الأجزاء الداخلية للكمبرسور. راح نشوف إن شاء الله كيف الcompression process or how the compression system is designed if you'd like to increase gas pressure from a low value to a higher value. طيب, let's go back again to the textbook or the handouts, as we'll say. Okay, so we just discussed the function of compressors, and we've seen the major differences between liquids and gases, and why compression systems are more difficult. Inshallah, we'll see why they are more difficult to design and more difficult to operate as well. بنشوف انه اللي بيشتغل مثلا في المستقبل في liquid system او process اغلبها liquid دائما بيكون مريح راسه، يعني اغلب الاحيان بيكون مرتاح، ما يكون عليه ضغوط كبيره مقارنه بالشباب اللي مثلا يشتغلون في process يعني اغلبها gaseous systems. طيب, now looking at the types of compressors, you can see that most of them are very similar to what has been covered already in chapter 1. Okay, we have the rotary screw compressors, rotary loop, and reciprocating compressors, and the centrifugal compressors. The only one that might sound different here is the first type of the positive displacement compressors, which is the rotary sliding vane compressor. Now, let me cover this one very quickly. The rotary sliding vane compressor, guys, is basically has a longitudinal veins, يقول لك يعني انه في زي الشرائح الطولية اخوان sliding radially in a slotted rotor. اللي هو sliding الشابة اللي تتحرك radially الشابة اللي هو على مستوى القطر، يعني في عملية دوران. جميل. in a slotted rotor mounted eccentrically in a cylinder. جميل. يعني الروتر هذا مركب بشكل أو في المنتصف. جميل. وموجود داخل السلندر. جميل. Let's have a look at, and those pictures are not actually so clear. Okay, this is a very good picture that shows how the sliding vane compressor looks like. Yeah, this figure shows the basic parts of the sliding vane compressor. You can see that this is the shaft, okay, and this is the rotor inside, guys, and the rotor rotates, as you can see, in this direction, and those are the vanes. The sliding vanes, number 3. Okay, they rotate radially, as the shaft is rotating. And we have the suction side of the gas, and we have the discharge side of the gas. So as you can see here, we have those sliding vanes. The gas will be trapped inside once it enters through the suction. There is a space between each vane and the other vane next to it, and once the gas flows into the housing of the compressor, some of the gas will be trapped in this volume. في جزء هنا يا اخوان راح ينحشر فيه الغاز يا اخوان، ويعني as it moves towards the discharge. جميل. هذا الحجم يصغر نسبيا. جميل. فعملية التغير في الحجم هذه or the reduction in the volume as a result of the rotation of the vanes and the design of the casing will cause gas pressure to increase. يبدأ أول ما يبدأ في السكشن بيكون الحجم أكبر ما يمكن، بعدين الديزاين حق الكيسنج يا إخوان بيبدأ يضيق حجم الغاز في الداخل، راح يكون أقل ما يمكن جهة الديسشارج. فالحجم في جهة الديسشارج راح يكون أقل ما يمكن، وبالتالي البريشر راح يرتفع. Let's go back again to the description of this compressor. The centrifugal force carries the sliding vanes and breathing from here, guys. Sliding vanes against the cylindrical case, with the vanes forming a number of individual cells in the eccentric annulus between the case and the rotor. هذه اللي ذكرتها قبل شوي يا شباب اللي هي السيلز، جميل، or a trapped volume اللي هي the volume between the two vanes. جميل. The suction port is located where the longitudinal cells are the largest. جميل. لاحظ يا شباب انه زي ما ذكرت الحجم السيل هذه يكون اكبر ما يمكن جهة السكشن. جميل. و as the rotor rotates inside the casing, جميل, what happens is that the size of each cell is reduced by the eccentricity of the rotor. جميل. اللي هو عملية الحجم يا اخوان، حجم السيل بسبب الديزاين حق الكيسنج. لاحظوا هنا، جميل، لو تلاحظون عندي هنا الحجم تقريبا كأنه يعني مختلف شوي. جميل. والحجم هنا عندي كبير شوي نسبيا. جميل. وهنا في الأخير بنلاحظ أنه الحجم في هذه الجهة يعني أصغر بكثير. جميل. that causes the gas pressure to increase. It doesn't really look that clear, but this is how it looks like. جميل. اللي هو إنه تصميم الكيسنج يعني ما بين السكشن، يعني في السكشن هذه الجهة راح يكون أكبر ما يمكن. جميل. and as it moves towards the discharge، هذا الديسشارج يا إخوان، وهذا السكشن. جميل. اللي يصير إنه حجم الغاز راح يصغر، وبالتالي البريشر راح يرتفع عندك. So yeah, let's go back again here. So the size of each cell is reduced by the eccentricity of the rotor، اللي هو عملية تمركز اللي هو الروتر نفسه. جميل. as the veins approach the discharge port, thus compressing the air. جميل. فالميكانيكال ديزاين هو لو نفكر فيه وش اللي يخلي البريشر يرتفع، اللي هو الميكانيكال ديزاين نفسه، اللي هو the gap or the gap between each vein and another. جميل. which creates the cell. لاحظوا عندي في الصورة هذه مش واضح، هذه عند الفين الأولى وهذه الفين الثانية اخوان، وهذه الفوليوم اللي موجودة جوا. هذه الفوليوم نفسها هي اللي تصغر بسبب موضع اللي هو الروتر في داخل الكيسنج. So this kind of compressors, guys, is used where low pressure and high volume gas is necessary for processing. هذا النوع من الكمبرسورز مثل ما يقول الكتاب انه ممكن تستخدمه اذا كنت تبحث مثلا عن process or you don't want extremely or you don't want high discharge pressure. If you want only low pressure and a high flow rate, high volume gas is necessary for processing. Let me write it down here. For low pressure and high flow rates. Let's go back again to that picture. As you can see here, it looks much better than the previous two. By the way, and this is very important, you will notice that the diameter of the suction pipe، قطر الحجم السكشن، جميل، دائما يكون أكبر من قطر الديسشارج بايب. بتلاحظون هذا الشيء دائما في الكمبرسورز اخوان، انه بالنسبه للليكويدز لا، السكشن والديسشارج diameter are the same، لانه مثل ما ذكرنا قبل شوي انه they are incompressible fluids اللي هم الليكويدز. بينما الغازز بتلاحظون انه the more you compress the gas, the smaller the size of your equipment and the smaller the diameter of the pipeline. هذه من احد الفروق اخوان المهمه بعد في مساله التصميم ما بين البامبس والكمبرسورز. Let me erase this again. So this is a very nice picture that shows the intake. You can either write the intake ports or the suction. You can write the suction side, just like the pumps. Okay. And you can write discharge side. نفس البump يا اخوان. You have a casing, you have a sliding vane, you have rotor, and shafts. طيب. So on to the next type of compressors. That's and we have already seen this very similar design in chapter 1 when we talk about the rotary screw pumps. And here we are talking about the rotary screw compressors, guys. Okay. So in this compressor, basically gas is compressed by the rotation or the rotating helical loops, and you have basically not loops in here. You have screws to it. That's probably a typing mistake. It's not helical loops. It is basically screws. Okay? That's probably a spelling mistake, guys. Okay, or a typing mistake. It should be screws. loops اللي هو الروتري لوب هذا النوع الثاني إن شاء الله نغطيه بعد شوي. This kind of compressors is very similar. The application of using this compressor is very similar to the pump, okay, in which high pressure and high flow rates are required. Okay, so let me smart the brush. Okay, so I'm reading from here, guys. It is used where high pressure and high volume gas, or in other words high flow rates. دائما الشباب بيتكلمون عن الفلو rates. يعني الفلو rate اللي هو the quantity that you'd like it to flow from one place to another is necessary for processing. Now these compressors consist of two rotors within a casing where the rotors compress the air internally, and there are no valves like the reciprocating pumps or compressors. Not reciprocating pumps and compressors, they have suction and discharge valves. Okay? Now in here we don't have that kind of valves, and these compressors consist of, again, let me read it, two screws within a casing where the screws, guys, compress the air internally. There are no valves, and these units are basically oil cooled. Okay, it says on the next page that those units are oil cooled or cooled generally, either with air cooling or water cooling. Where the oil seals the internal clearances. Now, inshallah, it's a totally different subject, اللي هو the sealing process. The sealing process, guys, is a process that is used to prevent the leakage from the internal parts of the pump to the outside. طبعا شباب اللي هو, let me just show you here what we mean exactly by that. At this point, as an example, you cannot have two metals in contact with each other. في المثل الأول يا شباب اللي هو casing, they call it the stationary part, and this is the shaft rotating, and they call it the rotating part. هذه الأجزاء يا إخوان معادن ما تقدر تخليها مع بعض أو ما تخليها على تلامس مباشر مع بعض. ليش؟ لأن شباب once you have two metals moving and getting in contact with each other, what happens is that there will be very high friction, and this high friction will generate sparks and high heat, and that might catch a fire right away. فالمعادن إذا صار في احتكاك مباشر ما بينها ممكن يصير عندي ارتفاع كبير جدا في درجة الحرارة ناتجا عن الاحتكاك، وهذا الشيء ممكن يسبب عندي حريق. ف they have to create some clearance between the metals. لابد أن يكون في فراغ بسيط يا إخوان ما بين المعادن، أو إذا كان في شيء يعني، أو إذا كان عملية الاحتكاك لابد منها يا إخوان، ممكن أن نحط الفراغ. We create a clearance like in here and we use what is known as the mechanical seal. mechanical seal عادة يا إخوان يكون قطعة مثلا مصنوعة من الربر أو يعني مادة مرنة نوعا ما وتتحمل الاحتكاك. It resists friction. جميل. This material can be placed here between the clearance existing between the shaft and the stationary part or the casing. And you know, as the shaft rotates, it will like this mechanical sealing, guys, will get damaged over time. That's why you need to check it every certain period of time and replace it if you want to. فهذا الميكانيكال سيلينج يعني يمنع اللي هو التسرب من داخل البمب الى الخارج، ولازم تشيك عليه كل فتره تتاكد انه ما صار فيه نقص فيه بسبب الاحتكاك، وتضطر انك تبدله من وقت لاخر. Now instead of the mechanical sealing, guys, they can use also a liquid sealing or gas sealing. انه gas او liquid ممكن يدخل ويطلع. مثلا على سبيل المثال as an example يعني I'm going to try to make it as clear as possible. Now this is the gas that you have inside the casing. It will get compressed and it will lead through the discharge. Okay. Now in this part here as an example, guys, they can inject some oil or air that can be used for cooling. And this air or oil must be at the same pressure as the fluid inside the casing. يعني لازم البريشر حق الفلويد هذا اللي داخل هنا على جهة الشافت، جميل، في الخارج، لازم يكون البريشر حقه نفس البريشر الموجود داخل المادة اللي موجودة في الداخل. ليش يا شباب؟ Because if the pressure here is the same as the pressure here, there will be no flow. يعني لا الغاز بيدخل على الأويل ولا الأويل بيدخل على الغاز. This oil can be used for cooling, or water can be used for cooling, or you can even have air. Sometimes they can have also nitrogen, or even if necessary, guys, they can use some of the gas that has been compressed as a sealing medium. يعني أحد الحلول إنه عشان أضمن إنه والله ما بي oil ولا water ممكن يدخل عليه فجأة الكمبرسور، إنه جزء من الكمبريسد جاز، هذا الجاز يا إخواني اللي طالع، ممكن أرجع أستخدم جزء بسيط منه في عملية إيش؟ السيلينج، لأن يكون البريشر حقه شوي مرتفع نوعا ما، جميل، فيدخل هنا بدون أي مشاكل ويطلع يسحب الطاقة الحرارية الزائدة. جميل. فيعني the sealing process is not your scope to cover، يعني هي شغلة الميكانيكال engineering، but that is actually very imperative to discuss and give you some basic idea about pump and compressor sealing systems. طبعا كل pump لها ديزاين مختلف وديزاين معين من ناحية operation, and that's why it requires a certain strategy for the sealing process. طيب شباب. Now, since cooling takes place right inside the compressor, the working parts never experience extreme temperature or operating temperatures. The rotary compressor, therefore, is a continuous duty air-cooled or water-cooled compressor package. And we have a picture that labels the basic parts of the rotary compressor. زي ما انتم شايفين يا اخوان, it looks very similar, or it looks exactly like the screw pump, the rotary screw pump. I mean, we have the suction. Let me show you now. We have, you can write either suction side or intake port, or you can even write discharge side or discharge ports. Other section of the discharge, and this is the driving gear. Okay, and we have the casing of the pump, and we have the helical loops or screws if you want to. Okay. And let's stick to what we have here in the book. But in chapter 1 it says that they are basically screws, rotating in opposite direction. It operates with, so the operation, let's discuss the operation. It operates with two helical rotors that rotate towards each other. يعني واحد عشان يدور clockwise والثاني يدور counter clockwise باتجاه معاكس. As the left rotor turns clockwise, the right rotor rotates counterclockwise. This forces the gas to become trapped in the central cavity. في الفراغات هذه يا شباب عملية الدوران هذه. It makes it trapped and it experiences a huge reduction in its volume. And the two rotors are attached to a driving shaft and provide energy to operate the compressor. الغاز يا شباب أول ما يدخل الجهة هذه راح يدخل عن طريق الكافيتي هنا في فراغ بسيط جدا. هذا الفراغ هو يسبب ارتفاع في البريشر حق الغاز جميل، وبالتالي يطلع عندك من الديسشارج leaving at a high temperature, high pressure, sorry. جميل. يعني you can almost use the same description of the rotary screw pump. جميل، يعني حتى لو توهقت شوي أو حسيت إن الكلام هنا يعني مختلف نوعا ما, and you have an objective question to describe the operation of the screw compressor, you can يعني write the one we have in the pump in chapter 1. لأن المبدأ واحد. جميل. We have two gears, one driving gear, one idle gear, two rotors or two screws rotating in opposite directions, and it is the exact same operation. Okay. Now on to the next page, guys, and as you can see here, you don't have to review this picture actually. On to the third type of compressors, which is the rotary loop compressor. Okay, and it's again very similar to what we had before with the rotary loop pump. Okay, rotary loop compressors are characterized by two kidney bean shaped, it says here, impellers used to trap and transfer gases. So again, guys, I'm saying this, we will stick to what we have here in the book. يعني هنا يستخدم كلمة impellers, chapter 1 يستخدم كلمة loops. They are actually supposed to be loops, all right, because it's again rotary loop compressor. So as an example, in true or false questions, if you have a true or false question and you have the same exact statement like this one, جميل، لو كان عندك true or false وعندنا نفس جتك هذه صح وخطأ مثلا, and it says two shaped impellers, okay, the answer is true. من الحين أقول لكم شباب جميل، يعني راح نستخدم نفس الستيتمنتس اللي موجودة في الكتاب مع تحفظنا على المصطلحات هذه. جميل. So there are two kidney bean shaped impellers used to trap and transfer gases. These two impellers move in opposite direction, just like the loop pump, on parallel mounted shafts, and the two shafts أكيد هذا شيء طبيعي. As the loops sweep across the suction port, compressed gases are released into what? Let me zoom in. Into the discharge line. The loops do not touch each other, and we already know that from chapter 1. And a few thousandths of an inch clearance or clearing exists between the casing and the loops. اللي خلونا نرجع للرسمة السابقة يا اخوان. اللي هو الكليرنس زي ما انتم شايفين عندي في المنطقة هذه. I have a very small clearance. في عندي فراغ بسيط جدا ما بين the loop, okay, and the casing of the pump. And we have already discussed why this clearance should be minimized as much as possible. Why? Because when we compress a liquid or when we pump a liquid or a gas, the pressure here will be higher than the pressure here. Okay, the pressure at the discharge will be higher than the pressure at the suction, and we don't want the gas or the liquid to flow backward. ما نبي الغاز أو السائل يرجع إلى السكشن مرة ثانية. فكيف نقدر نحل هذه المشكلة؟ بأنه إيش؟ we minimize the clearance between the loops and the casing of the pump or the compressor. لاحظوا الرسمة هنا عندي بسيطة جدا. It says here suction, impellers and discharge side. So they move in opposite directions, and compressed gases are released into the discharge line. The loops do not touch each other, and a few thousandths of an inch clearing exists between the casing and the loops. لاحظ هنا يا اخوان انه نفس المعلومات تقريبا اللي موجودة عندنا في البump أو في chapter 1 for the pumps are very similar to what we have here in this chapter. جميل. Now on to the reciprocating compressors. We already know how reciprocating compressors look like, and we in chapter 1 3 types have been covered, which are the piston, plunger and diaphragm pumps. Now when it comes to compression systems, they mostly use the piston compressor to compress the gas. Okay. Now the operating principle of reciprocating compressors is the same exact as the reciprocating pumps. نفس الطريقة يا شباب. جميل. إنه you have suction valve and a discharge valve, and you have a casing or a cylinder and a moving part, which could be either a piston, a plunger, or a diaphragm. But in gases, they usually use compressors, piston type. And the description is the same. If you read through the through what we have in here, you will see that we have the same description as the one we had before in chapter 1. So as an example, inlet valves open when the pressure in the cylinder is slightly below the intake pressure. When the piston moves backward, it creates vacuum, or it creates a space inside the cylinder, and that space causes the suction valve, which is, by the way, a check valve, to open, and that withdraws some of the gas inside the casing as the piston moves backward. هنا البستن يا اخوان، يعني حتى ممكن استخدم الصورة حقت شابتر 1 افضل بكثير. الصورة الموجودة في شابتر 1 افضل بكثير يا اخوان، والديسكريبشن حتى انا من وجهة نظري افضل. اللهم الشيء الوحيد اللي ممكن تغيره في الديسكريبشن اللي هو if you have a word liquid you just replace it with a gas. So the inlet valve opens when the pressure in the cylinder is below the intake pressure, or when it creates a space as the piston moves backward. So the gas will enter the cylinder, and after that, when the piston moves forward, okay, that causes the pressure to increase in the cylinder to increase, and that's where the suction valve gets closed and the discharge valve gets opened. إذا بدأت البستن تتحرك بشكل أمامي، هذا يضغط الغاز يا إخوان، وبالتالي يفتح عندنا اللي هو الديscharge valve. جميل. ويقفل عندنا إيش اللي هو السكشن valve. طبعا نفس الفكرة بالضبط اللي هي يا إخوان the internal combustion engines that we have in our cars. البساتين أو السلندر والبستن، خليط الغاز والوقود والهواء لما يدخل نفس طريقة البيستون كومبرسور بالضبط. يعني it looks actually like a piston compressor. يدخل الغاز خليط الوقود والهواء مع بعض داخل السلندر. ليش؟ لأنه السكشن فالف فتح لأن البستن تحركت للأسفل فإت created space. بعدها البستن it moves forward and after that you have the ignition and that causes that little explosion inside the cylinder. And when the piston moves forward the discharge valve opens and the suction valve gets closed. يفتح الديسشارج ويطلع الغاز الناتج عن عملية الاحتراق إلى الخارج. ف يعني مثل ما ذكرت اختصروا الوقت على أنفسكم في مذاكرة الشابتر هذا تقرونه وممكن تستخدم نفس الديسكريبشن. يعني حتى لو جاك مثلا سؤال في الاختبار عن labeling the parts of the centrifugal of the piston compressor, I will most likely use the picture we have in chapter 1 for the pump. نفس الطريقة ونفس المبدأ ونفس كل شيء بالضبط، ما في أي فرق. اللهم بدل الليكويد بيكون عندك إيش؟ يكون عندك جاز. جميل. طيب. After that it talks about the operation cycle in reciprocating compressors. هذا الاوبريشن سايكل عملية التشغيل يا اخواني اللي هو how the piston moves backward, your backstroke والفورورد ستروك. نفس الكلام بتلاحظونه هنا اللي موجود في chapter 1 تقريبا. يعني حتى شوف chapter 1 ممكن في الشرح أفضل وأكثر يعني في الديسكريبشن. جميل. And finally the centrifugal compressors. The centrifugal compressor it works exactly the same as the centrifugal pump. جميل. And you have a shaft and a rotating impeller inside the casing. The gas flows right into the center of that impeller. Okay, as you can see here, it's the same picture actually, just like the one we had before in chapter 1, sorry. Yeah, but probably what you are going to see here is that there are very minor differences that we have here in terms of how the size of the volutes in the compressors might not be the same as what we have in the pumps. Okay. But anyways, guys, let's have a look at what we have here. Centrifugal compressors accelerates the velocity of the gas, which is then converted to pressure as the gas flow leaves the volute and enters the discharge pipe. Usually it operates at high speeds, more than 3000 RPM, and it delivers higher flow rates than positive displacement compressors. احنا مثل ما عرفنا انه في السنتريفيجال بامب نفس الكلام هنا بالضبط. إن it is used for low to medium discharge pressure applications and high flow rate. إذا تبي high flow rate discharge pressure ما يكون عالي مرة. هذا النوع من الكمبرسورز أو البامبس يعتبر هو المناسب. جميل. And the description of the process, the compression process is exactly the same. We have this is the suction. Jamiel, and you all know how it looks like. And as the impeller rotates, okay, and the vanes you have on the impeller here, that gas will be pushed from the center towards the edge of that impeller, and that causes the kinetic energy to increase. Okay, and as the gas leaves the casing through the volute, guys, what happens is that it will decelerate, the speed will decrease, and that causes the pressure inside the casing to increase. Okay? And then after that, the gas will flow through the discharge side of the pump. Okay? فنفس الكلام حتى لو جاك سؤال مثلا عن labeling a part of a centrifugal compressor, most likely I will use the same picture like what we had before in chapter 1 when we talk about pumps. إنه ديزاين واحد تقريبا وما في أي فرق. جميل. طبعا في الأخير عندنا هنا يا إخوان نتكلم عن مسألة بسيطة جدا اللي هو typical compressor startup procedures. Check valve line up on the compressor and associated equipment. يعني هذه أمور ما هي مطلوبة مرة. إنه خلال البروسيجر يا إخوان if you have a compressor and you'd like to start it up or shut it down, there are certain procedures that you have to follow. جميل. يعني if there are any valves يا شباب you have to check here is the verb يا شباب. جميل. مش check valve اللي احنا درسناه. جميل. you have to check the valves how they are lined up. يعني إذا في كان block valve طبعا السكشن والdischarge يا شباب لازم يكون في block valve or on off valve. يعني لابد أتأكد إنه مفتوح مثلا السكشن valve في البداية بعد ما أسوي warm up للكمبرسور. جميل. and then I will check compressor oil levels and bearing cooling water system. مثل ما ذكرنا يا إخوان قبل شوي مسألة السيلينج والcooling system for the mechanical parts when they rotate. Be sure that all compressor controls are set correctly. هذه مسألة control systems. جميل. Turn on the compressor and monitor equipment and process until conditions steady out. لين يعني تشغل الكمبرسور بحسب البروسيجر وبعدين تراقبه وتتأكد إن كل شيء ضمن القيم أو القراءات عندك اللي هي البريشر والتمبريتشر والفلو ريت وما إلى ذلك ضمن القيم المطلوبة عندك. جميل. طيب يا شباب طبعا يعني that's not everything يا شباب compressors actually. The book from my point of view is supposed to discuss an important issue that we have in compressors. تذكرون في pumps chapter 1 we had an issue with cavitation and centrifugal pumps. Now in compressors guys, generally the centrifugal compressors, we have a very famous problem known as the surge phenomenon. هذا السيرج فينومينا يا إخوان أحد أكبر المشاكل اللي تواجه عادة السنترفيجال كومبرسورز. المشكلة إنه يا إخوان في السيرج فينومينا حسب فهمي المتواضع إنه the pressure after the compressor gets higher than the pressure at the discharge of the compressor. لو في المنطقة هذه يا إخوان يعني خلونا نقول إنه this is the discharge piping. Okay. هذا discharge. جميل. هنا عندي let's say this is P2 and this is here a point where we have P3. جميل. أحد أكبر المشاكل ممكن تواجه الكمبرسور يا إخوان إنه P3 هذه تصير تقريبا مساوية أو ممكن حتى تصير أعلى من P2. هنا تحس إن الكمبرسور يعني فعلا جالس يعاني يا شباب. الكمبرسور يعاني يحاول يضغط الغاز ويخليه يمشي بس الغاز مو راضي يمشي وبعض الأحيان بالعكس يعني يرجع بالاتجاه العكسي. جميل. ف it looks like you have some reverse flow. جميل. ف surge phenomena will destroy compressors guys. If you don't compress the gas, the impeller will rotate and as I said before, gas temperature will increase. But the problem here is that now the gas is trapped inside the compressor. It's not leaving. إن P3 أعلى من P2 أو تقريبا مساوية. جميل. فتبدأ الحرارة ترتفع بشكل كبير جدا في الكمبرسور ما هو زي الليكويدز أو البامبس وهذا الشيء راح يحدث ضرر كبير جدا. ف one solution يا شباب to fix this surge phenomena is that they have to reduce the pressure at P3 and one way to do that is by having a pipeline known as the kickback line. هذا الكيكباك يا شباب يسمح للجزء من الغاز اللي موجود في النقطة هذه P3 إنه يرجع مرة ثانية ويدخل على من جديد على السكشن حق البامب. جميل. طبعا هنا راح يكون فيه زي الكنترول فالف. جميل. في نظام تحكم هنا. جميل. الكيك باك هذا عادة يكون مقفل في الظروف الطبيعية، المفروض يكون مقفل، لكن إذا صار عندي هذا السيرج فينومينا إن البي 3 صار تقريبا يعني قريبة جدا من بي 2، وإحنا نعرف يا شباب إنه إذا كان الفرق بين بي 2 وبي 3 صار صغير جدا، الفلوريت راح يكون قليل جدا، والغاز يبدأ ينحشر هنا في الكمبرسور. زي ما ذكرت الكمبرسورز the compression process increases the temperature of the gas. فأنت عشان درجة حرارة المعادن اللي داخل أو الأجزاء الميكانيكية داخل المعدن الكمبرسور ما تبيها ترتفع كثير، لازم الغاز هذا يمشي، يطلع من الكمبرسور يروح على البروسيس اللي بعده. جميل. In order to solve this issue as an example they use what is known as the let's so here from here we use what is known as the kick back valve. يعني حتى بعض الأحيان الكيك باك فالف هذا تلقونه موجود وين؟ في البمبس عشان تمنع مسألة الكافيتيشن. جميل. يعني في الحقيقة بتشوفون يعني كثير من أنواع البمبس الموجودة في المصانع عندها نظام الكيك باك هذا، إنه علشان في الكافيتيشن عندي في البمبس مثلا كيف أقدر أرفع السكشن بريشر إني أسحب جزء من الديسشارج بريشر بيكون أعلى. جميل. فأسحب جزء من السائل في الديسشارج وأرجع مرة ثانية ريسايكل back again to the suction side of the pump. يعني حل واحد لمشكلتين مختلفتين في البامبس والكمبرسورز اللي هو يسمونه الكيك باك بامب. اوكي. جميل. هذه من الامور اللي صراحه هذه المفروض يكون موجود في الكتاب. جميل. هذا المعلومه وهذه المعلومه لازم يكون موجود في الكتاب. طبعا في السيرش فينومينا يا اخوان لها تفاصيل كثير، هي اسبابها والديزاين حق الكمبرسور، يعني تفاصيل كثيره، يعني it's not your scope at level 1 to cover this. فانا شرحت لكم بابسط طريقه ممكنه، لكن ما تجي بعدين في المستقبل تشوف كمبرسور وتتفاجأ بمساله الكيك باك فالف وليش عندي جزء من الغاز يرجع مره ثانيه على السكشن. تذكروا يا اخوان ان الكيك باك فالف علشان مسألة الكافيتيشن في البامبس والسيرج فينومينا في الكمبرسورز المفروض يكون مقفل في الحالات العادية، ما يفتح إلا إذا صار فعلا البريشر داون ستريم اوف ذا بامب أو ذا كمبرسور اللي هو بعد الديسشارج بمسافة صار قريب جدا من الديسشارج أو ممكن مساوي، يفتح الكيك باك فالف هذا علشان يرجع جزء من السائل أو الغاز من الداون ستريم إلى السكشن حق البامب أو الكمبرسور. طيب so that's it actually for the compressors, and as you can see it took me only a couple of minutes to cover all these things up. بالنسبة لكم إن شاء الله ما راح ياخذ منكم وقت طويل عملية المذاكرة، ذاكروها بشكل سريع. ومثل ما ذكرت بعيد وكرر إخوان بعض المصطلحات ما إحنا متفقين عليها هنا، بس إنه يعني when it comes to the quizzes or exams we will stick to what we have here in the book. يعني قال إن لوب نستخدم لوب، قال إن امبلر، قال عن اللوب كومبرسور إنها امبلر، هنستخدم إيش كلمة امبلرز. طيب the last thing that I would like to cover for today guys is showing you is when we talked about the fact that compressing a gas must be done in multiple steps. From low pressure to high pressure needs to be done in multiple steps. I'm going to show you right now using the centrifugal compressor as an example. المشكلة مثل ما ذكرت الكبيرة يا اخوان انه في compressor gas you will extremely increased gas temperature، وهذا الشيء راح يأثر على المعدن ويسبب لك إما حريق أو يسبب لك تسربات ناتجة عن تمدد المعدن. ف you have a problem here، جميل، إن you need some sort of a way to cool the gas down. جميل، إنك لازم تبرد الغاز بعد ما تصير العملية إيش؟ compression. So let's say that you have a gas at 1 atmosphere, okay, and you would like to compress it up to 40 atmosphere. Okay. راح أوضح لكم إياها بشكل بسيط جدا. You need to have a multi-stage compressor. كل الأنواع اللي شفناها يا إخوان في البامبس والكمبرسورز هذه يسمونها single stage. عندك one suction, one casing, one discharge, that's it. نفس الكلام بالنسبة للكمبرسورز هنا. يعني for the multi-stage compressor you will see guys that we have one motor, okay, or one driver. It could be an electric motor or a turbine. We have one shaft, and in the multi-stage compressor it is a very long shaft, and instead of one casing we have multiple casings. خلونا نشوف كيف في الشكل، يعني راح أحاول أرسم لكم بشكل تقريبي. So as an example, I'm going to try to use some of the shapes that we have in here. Okay, so let's say that this is the motor. Okay, and if you have this compressor, guys, it would be most likely a turbine. Okay, the turbine, guys, you have steam flowing in. Steam at high pressure, high flow rates flowing in. It hits the blades of the turbine, and the turbine rotates, and that causes the turbine. The rotation of the turbine will cause the shaft to rotate. هذه الشافت يا إخوان لاحظوا يعني I'm showing you that it is actually a very long shaft. In fact, this is steam in. And we have steam out. هذا اللي هو الدرايفر سايد، مش البروسيس سايد اللي احنا مركزين عليه في الكيميكال انجينيرنج. Now, if you have as an example, guys, this gas from 1 atmosphere to 40 atmosphere, you will have to compress it in a multi-stage. ايش معنى multi-stage؟ إن you don't have only one casing, okay, and one impeller. You actually have more than one, 2, 3, 4, sometimes maybe up to 5 or even 6 stages. So you have the turbine rotating. It is connected to a shaft. This is a very long shaft, and let's say that since the pressure is 40, we have 4 stages as an example. This is the first stage on the same shaft. You can see that all of them are on the same shaft. Now, this is the second stage, and this is the third stage, and this is the fourth stage. And you can see that the size of the first stage is the largest, and the volume of each casing, or the volume of the casings, gets smaller as you increase the number of stages, or as the pressure increases. لاحظوا انه the fourth stage is the smallest، حجمها هي الأصغر، لأنه الغاز راح يكون مضغوط بشكل عالي شيء طبيعي إن لابد يكون حجم الكيسنج أصغر. جميل. And inside each casing we have impellers. جميل. We have impeller, one impeller, and one impeller in here. جميل. طيب يا شباب. So the gas will flow in through the suction of the first stage. جميل. هذا gas in. Will flow in through the first stage. This is a centrifugal compressor, guys. Okay, it will get compressed and then it will leave through the discharge. Now, the problem is, guys, as I said before, is that if you compress the gas and keep compressing the gas, the temperature of the gas will increase, and that will result in damaging the compressor. So in order to solve this problem, guys, by the way, the pressure here is 1, and the discharge pressure here will not be 40, it will be, as an example, 10 atmosphere. Okay, so each time you increase the pressure by 10 until you get to 40 atmosphere. Now, if you compress the gas from 1 atmosphere to 10 atmosphere, the pressure will increase, and so does the temperature. Temperature راح ترتفع. So how can I solve the problem of the temperature increment? It is very simply by using a heat exchanger. Okay, فراح نستخدم heat exchanger for cooling. جميل. يعني في cooling water مثلا يدخل الجهة هذه، جميل، ويطلع يسحب الحرارة الزائدة اللي موجودة في الغاز. جميل. Now you solve the problem of the temperature. جميل. But this solution, guys, creates another problem. انت الحين بردت الغاز، ضغطت الغاز بعدين بردته، انت حليت مشكلة عندك. جميل. Now the other problem that will result from compressing the gas and then cooling it down, is that some gases, when they are compressed and then cooled down, they condense. بعض الغازات إذا ضغطته وبعدين بردته يبدأ يتكثف، يبدأ يتحول إلى الحالة السائلة. جميل. زي علب العطور عندنا، زي على سبيل المثال غاز البيوتين عندنا، جميل، الدوافير الموجودة، تشوف الغاز جوا تخبى سائل. مثلا ديودرنس اللي هي الله يعزكم، اللي هي مزيلات العرق، هذه اللي المضغوط، الغاز المضغوط، تخبى العلبة سائل جوا. ليش؟ هو غاز مضغوط وبعدين برد إلى درجة الحرارة الطبيعية، فالغاز تحول إلى الحالة السائلة. This process, the compression plus cooling, will result in condensing some of the gases. زي الفريون سيستم عندنا بعد في المكيفات والثلاجات نفس النظام. بعد الكمبرسور في عندي هيت اكسشينجر اللي هي كوندنسر، جميل، او مبرد الفريون. فالفريون راح يطلع من المبرد بحالته السائلة. جميل. طبعا we know يا شباب that compressors are designed to only deal with gases. جميل. زي ما البامبس مصممة نتعامل مع الليكويدز فقط. In order to solve this problem, guys, what we can use is that we can have a simple drum or vessel, okay, that can separate liquids from gases. يدخل الميكستشر ليكويد وغاز داخل الدرم هذا، ينزل الليكويد تحت بسبب الجاذبية الأرضية، and then it could be pumped. جميل. يعني ممكن يكون في pump هنا، جميل, that can be used to pump this liquid back again for another process. And the gas will flow up through the second stage. جميل. هذا عندك drum. I can write it with my own fingers like this, or a separator they call it, or a vessel. جميل. The gas will now, after it has been cooled and the liquid is separated from the gas after cooling process, okay, the gas will flow up back again to the second stage. Now it is almost at say at 9.5 as an example. Why I have 9.5, not 10? Because when the gas flows through the heat exchanger and through the drum, there will be some pressure drop. راح يصير في انخفاض بسبب الاحتكاك بسبب مثلا البافولز او the way the gas flows inside the tubes. جميل, more it goes back and forth, up and down. That creates some restriction, and with the high friction as well, some of the pressure will drop. The pressure will go from 9.5 to, let's say, 20 atmosphere. Okay, and then again it's the same process. You have another cooler to cool it down, another heat exchanger, okay, to cool it down. لاحظوا الآن الشباب إنه حجم الهيت اكسشينجر في السكند ستيج أصغر من حجم الاكسشينجر في الفيرست ستيج. So again you cool it down, and then if some of the gases condense, you have another drum that is now smaller than the first drum. الدرام الأكبر حجمه هو الأكبر. ليش؟ الدرام الأول هو الأكبر لأنه الغاز pressure is low. The lower the gas pressure, usually the higher the volume. جميل. And again the same thing, liquid goes down, it could be pumped to another process, and then the gas flow to the third stage. كان discharge pressure 20, فممكن suction pressure يكون as an example 19.5 or 19, though we usually want very high pressure drop. And now then it flows to 30. Third stage will compress the gas again up to 30, and it's the same story, guys. You have a third heat exchanger for cooling, and then a drum to separate liquids from gases. The liquid goes down, it could be pumped again, and the gas flows upward to the fourth stage, and then finally it gets to the required pressure of 40. Usually in the last stage, guys, you only have a cooler to cool down the gas, and then it depends if you need a drum or not. يعتمد هل تحتاج أن يكون عندك drum أو لا. بعض الأحيان تحتاج, بعض الأحيان ما يحتاج يكون عندك. So as you can see, guys, this is an example, a very simple example that demonstrates the multi-stage compressor. لاحظوا إنه it is the same driver or the same turbine. I have a very long shaft, جميل, and I have multiple casings. In each casing we have an impeller that rotates on the same shaft. جميل. If you have a gas from 1 to 40 atmosphere, you probably need 4 stages, from 1 to 10, and like approximately from 10 to 20, from 20 to 30, and from 30. And the pressure here, it's a small pressure drop. As an example, 29.5. And because of the temperature, each time you compress the gas, you need a heat exchanger for cooling the gas down. And because some gases will condense, لأنه كل ما ارتفعت البريشر يرتفع البويلنج بوينت زي ما شفنا في البويلرز. Compressing the gas and then cooling it down will create another problem, which is the probability of gases to condense. How to solve this issue is to basically separate liquids from gases in a drum, a very simple drum, guys. And then after that you can allow the remaining gas to flow to the next stage until you get to the required pressure. هذا الفيديو مهم جدا، أو هذا الشرح مهم جدا، لأنه usually you'll see centrifugal compressor is the most common type being used, and for huge flow rates and high discharge pressures, you will see something very similar to this. Multiple stage compressor وheat exchangers. لاحظوا شباب مثل ما ذكرت إنه everything you have in this system gets smaller as the pressure increases. يعني حجم الكيسنج في الفيرست ستيج والاكسشينجر في الفيرست ستيج والبايب السكشن بايب لاين فيرست ستيج أكبر من الديسشارج حق الفيرست ستيج. جميل. والسكشن حق السكند ستيج أكبر من الديسشارج حق البايب لاين للسكند، وهكذا. كذلك حجم الاكسشينجرز، وكذلك حجم الكيسنجز كذلك. I really hope that most of you will see this video and realize or recognize this kind of compression systems. لاحظوا ان السيستم مش compressor هذا، لانه فيه compressor heat exchangers, drums and pumps as well. You will need a pump to pump the liquid that will settle here at the bottom of each drum. جميل يا اخوان، يعطيكم العافية واتمنى لكم التوفيق ان شاء الله.